Welcome to this class of computer programming where we are going to be discussing about pointers. Now, pointers are probably the most complicated or complex topic that we are going to deal with in this course. Now, here I should mention that in doing very basic mechanical engineering programs, you will probably not need pointers. But if you want to means go or delve deeper into the topic or subject of coding, where you need to manipulate memory and you need to understand at the core how a compiler allocates memory, how it handles different types of data types, you probably need to understand pointers quite well. So again, for lack of a better word, I would say that this is the most complex topic that we are going to be dealing with. But understanding a basic understanding of pointers actually clears up certain concept regarding both arrays, single dimension arrays and multi-dimension arrays, as well as certain other topics related with memory allocation and how a compiler actually handles different types of data types. So without further delay, let us move to the actual topic. As you can see here, we are towards the end of our syllabus. And in today's class, we are going to introduce pointer variables and parameter passing. Now, what are pointers? Pointers actually deal with addresses, and in continuation of that, it basically deals with memory locations. So we can say that these are certain special type of variables which only store the address of some other variable or data type, data items. I'll repeat again. These are certain variables that only store addresses of other variables. You cannot store other type of data in these pointer variables. They can store only addresses. So basically, you can say these are address books. And quite obviously, they represent the location rather than the value of a data item. If you think of a memory location of a computer hard disk, you will find that it's quite analogous to the table that you can see on the screen. There are certain spaces, those are memory locations, and each memory location is tagged with an unique address. For example, here you can see that the first box or memory location has the address of 1000. I have written it quite arbitrarily. Actually, in actual computer hard disks, it may not be in this format, but it is quite similar to this. Now, if you declare a variable, say of the name var and data type int, what happens is that a particular location in this memory will be reserved for this variable. Let's say it is arbitrarily, let's say that this is this block having address of 1002. So when you initialize this variable or you put a value inside this variable, what happens is that the compiler puts this value of 5 in that memory location. Basically, you can think of a street having many houses and each house having a particular address. So with that address, you can uniquely identify a particular house. So this is what happens in case of pointers as well. So whenever a variable is declared, the compiler or the system allocates a memory location or locations, depending on whether it's an array, to hold the value of that variable. And as every byte in memory has a unique address, this allocated location will also have an unique address. This is the premise of the pointers. So each memory location has an address, and that address uniquely identifies that particular location. So from this basic discussion, we have the notion that a variable or data item is associated with two things. One is the value stored, obviously at a specific memory location, because that variable is attached to a particular memory location. And the second is that its address of that memory location. So we have this value 5, and it is located at an address of 1002. Now, obviously, you need to consider that this is an integer data type. Within our computer memory, every stored data item, it has to occupy one or more contiguous memory cells. If it is a character, it will cover, or it will take up only 1 byte. If it is an integer, more likely it will take up 4 bytes. Float, also 4 bytes. Double, maybe 8 bytes, depending on the computer architecture. So the number of memory cells required to store the data item depends on its type, whether character, int, double, etc. So that has to be kept in mind as well while thinking about memory locations and addresses. Here we are specifically looking at the case of integers. So now let us say I want to access the value of this variable. We have already done this. We call it by its name. The variable name is defined. If we invoke that name, we get a direct reference to that value stored inside that variable. From the first class onwards, probably we have been doing that in our programs. But there is also another way of accessing that value, and that is known as an indirect reference. You can do it with the help of its memory address. Think about the street I was talking about. Your friend comes to this street and shouts your name. So you will respond. And then somebody else comes and he knows the address where you are residing. So he will go down that street, go to that specific address. He will knock on the door or ring the bell, and then also you will respond. So there are two different ways of accessing this value, as there is to calling you. One is invoking its name, which is known as the direct reference. The other is to go for an indirect reference, whereby you refer to the address or the memory address of where this variable is stored. Now you consider this, that the addresses are simply numbers, as I have shown here. May not be in this format, but they are still numbers. And they can be assigned to some variables. Because they are numbers, these values can also be assigned to other variables. Those particular variables, those specific variables are known as pointer variables. And they are unique in a sort of way because they can only store the addresses. So that is the concept of pointer variables.
Sir,
Yes.
sir, one question. The
Go ahead.
address, what we are telling, this is also a number or something like that. So
Yes.
it is also data. So
Yes.
it must also be stored in our computer, means our
Exactly. That,
software. So
yeah. It has to be stored. So what we are talking about is, note that it is a pointer variable. So as soon as you define a pointer variable, that also needs to be stored somewhere in the memory location. That gives rise to also a higher concept of pointer pointing to a pointer. So we'll not go into that, obviously. But we can definitely think about another memory location where this address is going to be stored. So this goes there. Now you can see that this is some other memory location. It is denoted by the address 8052, which is quite different from here. And also this is, I have written it quite arbitrarily. But when you define a pointer variable, now that pointer variable has to have an address, and that address is this one. And now this address goes into that location. Now this is where this gets complicated, because it try to always picture it in terms of this sort of a table. Otherwise, it will be quite difficult to imagine how these things work. So as a pointer is a variable, the value is also stored in some other memory location. As you were referring to, it has to be stored in some other memory location. And in this example, that memory location, as you can see, is 8052. So the address of variable var here can be assigned to a pointer variable. This pointer variable, now let us say that it is defined as p. So what we have considered up to now, we have considered declaration of an integer variable named var. We have stored a value of 5 inside it. And we have seen from this table, analogous table, that this has a memory address. And this memory address can also be assigned to another specific type of variable, which is a pointer variable represented by p here. And this pointer variable now has an address 8052. What does the pointer variable contain? What is there inside it? Address of the integer variable here. So we can then say that this pointer p is pointing to the variable var. That means this location. Because it has its address inside, it points to this variable. Again, difficult to visualize, but a task a little bit easier. So now we have two different variables. One is var, which is a normal variable. Let's say this one is the normal variable, and this is the pointer variable. Both have some addresses and both have some values. So we have already said that a variable is going to have some value inside it, and it is going to have some memory location. So what about the normal variable? It has got a value of 5, and this value of 5 resides in this address. Now here we have a pointer variable that points to that normal variable var, this one. What is inside this pointer variable? The address of var. And what is the address of the pointer variable itself? This is 8050. So a lot of different aspects are related to these two variables. One, a normal variable, the other one, a pointer variable. Now, how do we declare a pointer variable? There is, of course, a particular syntax following which you declare a pointer. And quite obvious that you need to declare the variable as you do with normal variables before you put it in use. So what is the syntax? The syntax is data type, then note this star. that indicates that the variable being declared is a pointer variable. And then you have the variable name, which follows the same rules and regulations and syntaxes of the normal common variable name. So what is different here? Different is this asterisk mark. So you have data type. So that could be either int or character, char or float or double. Any of the data types could be there. Then space, asterisk mark, followed by the variable name. This asterisk mark indicates that you are declaring a pointer variable. Now, as soon as you declare this, what happens is that this pointer variable is assigned a memory location. Think about that second table. It was assigned a value of something like 8052. So when you declare a pointer variable, it will be assigned a memory location. And pointer variables point to a variable of specific type. You are also specifying the type by the syntax data type to which this pointer would point to. It could either be int or float or character or double, like that. Here are some examples. I can define a pointer variable of integer type. As you can see here, this is int, then asterisk. This is the name of the variable. That is ptrx. Here you have a float type pointer variable declared. You have ptr underscore now. Character type can also be used. This I have already mentioned that pointer variables must always point to a data item of the same type. That means if you have defined a pointer of integer type, you cannot use that pointer to point to a floating point variable. Now let us look at this example on the right hand side here. What do you think is being declared here? This is a pointer of name ptrx and its type is int. But what about this variable? Is it a pointer variable or it's a normal variable? This one is going to be a pointer. This one is normal. If I had to define this as a pointer as well, I would have had to write int comma star value. Then it would have been a pointer value. So this star only works for the variable name to which it is prefixed. As you can see here.
Sir, one thing, sir. Um,
Yes.
if the pointer variable is, float,
Hmm.
so it's like that the address of the variable is stored in, I mean, that, I mean, suppose address of a variable is 1.000000000 something, and the next one will be like 0000001, like that. In an
No,
array.
the address cannot be a fraction, can it?
Then what is the
Address is
point
not.
of having
No,
float or
float.
character?
It means that what it refers to, the pointer variable. The pointer variable would always contain an address. But address of what? Address of an integer, address of an integer variable, address of a floating point variable, or address of a character. That is what is determined by this data type here.
Okay,
You
sir.
get that?
Okay,
The
okay.
pointer is going to be always an uh, It is going to be
Integer, right?
always an address. Let's not say integer, it's going to be an address. If you say integer, it gets confused with the integer variable. I would
Okay.
say it's an address. Okay. So now that address, what is it for? Is it for a double type variable, or is it for a floating point type variable? That is what is determined by this data type. Okay. So let's proceed. Here we have talked about declaration. Now you have to initialize as well. So once you have declared the variable, it can be made to point to a variable using an assignment statement. When I write that this is, let's say, I have defined this pointer. Right now, after initialization, it does not point to anything. You have to initialize it to make it point to a particular variable. And how we can do that? We can do it like this. This is the same statement that we had discussed just now. This is how the assignment can be made. This is how the assignment is made in case of a pointer. So you see that the pointer variable is equal to, then we have this ampersand. What is ampersand used for? We have an idea of this from scanf.
Address.
Ampersand refers to address. That is quite correct. So pointers store addresses. What we are doing here is we are taking the address of this variable var using this ampersand sign operator and storing it in this variable. Now this is wrong. Why is it wrong? Because we have defined or declared an integer type pointer, but we are pointing to a floating point variable. This is going to give you an erroneous value, an erroneous output. So you have to be very careful about the type of the pointer. And also, another good programming practice is to include the phrase or the letters PTR in pointer variable names. That makes it clear that these variables actually are pointers, pointer variables, and they need to be handled appropriately. Now let us talk about certain address operations. We have already seen some address operations, but let us just again reiterate some of these. There are two unary operations to consider here. One is the address operator, that is the ampersand. If it is prefixed with a variable, example ampersand var, it gives the address of the variable. Now there must be something there also which can be used with a pointer to give the value of the pointer itself. That means what is stored inside the thing that is being pointed to. So that is done with respect to this dereference operator. This is also known as indirection operator. It is represented by asterisk. When it is prefixed with a pointer variable, example asterisk ptrx, it gives the value of the variable pointed at by that pointer. As already mentioned, it is also known as the indirection operator. So you have the pointer and you have the data on two sides. Now if you do star, that is the asterisk followed by the pointer name, you get the data. And if you do this, that means ampersand followed by the variable name, the data, then you get the pointer. So it's a cyclic sort of thing. You try to remember, picture this graphics. Probably that will help you remember the concept. Now let's take an example. The concept may not be, I quite clearly understand that it is not exactly or clearly understood at this point, but let's try to take certain examples and see whether we can clarify those doubts. Now this is the first example, a simple program. This is the main function. We have first of all defined an integer variable. In fact, two integer variables, a and b. Also, a has been initialized to 10. In the next line, we have got a pointer variable. It's defined according to the syntax that we have discussed. Int, the data type, then asterisk, the star, ptr. Now, this is not a dereference operator. This is the part of declaration. Dereference parameter comes later. Now, how do we store the address of A in this PTR? I have already seen it. PTR would be equal to the address of A. So that is how a pointer is initialized, or it is given an address of this variable A. Now here, if I had written this, that is completely wrong. Star PTR, it means it's a value. Ampersand A is an address. So there is a mismatch. So that's why this is wrong. Try to keep that in mind. You cannot do it like this. In fact, this is the pointer variable as declared here. So just writing its name is good enough to invoke that pointer variable. So pointer variable name equal to ampersand A, address of A. In the next line, what we have done is B, this second normal variable that was there, is equal to star PTR. Now, what do you think this will do? What will be the value here? B? B will have the value of 10. Both will be 10 now. We have stored 10 inside variable A. We have defined a pointer and stored the address of A in that pointer variable. Now we are dereferencing that pointer variable and saying that whatever it points to, this pointer variable points to, should be stored in B. So what was this pointer variable pointing to? This variable A, what was its value? 10. So B will receive the value of 10 from here. So if you print it out, you will see that both will come out to be 10. Here also you can see that in printf, I have used asterisk PTR, star PTR. So that means whatever the value it is pointing to, that is going to be printed here. Let's look at another example.
Sir,
Okay,
if I have printed just PTR, then it will show the address of
it will
A,
show
right?
the address of A, but then you write a percentage P. Instead of percentage D, you should write percentage P. We'll see that later on.
Okay, sir.
But before we move on to the next example, this is basically saying B is equal to A. In a roundabout way, that is what we are saying here. This is the second example. Now here we have defined a pointer variable of a given name, ptr underscore var. There's the second variable var. First of all, we have stored var equal to 5. Then we have stored the address of this variable into this pointer variable. And then we have changed the value of var to 10. So what should be printed here? First of all, this is quite simple. This is var. So whatever is there, this is going to be printed as 10. Now this is the address we are talking about. Whatever is inside that address, that is going to be printed. So this is again going to be 10.
10.
Yeah. So both of these will be 10. So these are very simple examples. Right now, let me move over to the Dev C++ platform. And here we will try to write some program for pointers. Let's say this is, I'll correct the date, demonstration of pointers. And this program is nothing specific, but it tries to clarify certain doubts that you may be having regarding pointers. So ptr c, and the variable, that normal variable, let's say it is c. Let us say we have stored a value of 100 in this, and now let's printf address of c. As I said, you can put %p to print an address. New line here. I want to print the address. What do I have to write here? %c. That gives me the address. Just copy this. Paste it over here. Right. Value of c, %d. Up to now, I have not yet invoked any kind of pointers. This is just basic printf, basic programming using normal variables that we have been doing previously. Now we'll write ptrc is equal to address of c. So we are storing the address of c in this pointer variable. In this step, in this line, we are printing the address of the pointer. So this is going to be supposedly different from the address of C from our understanding. So we'll see whether it happens like that or not. Here, right, content of the pointer. What is the content of the pointer? Here. So that's all. So we'll save it first of all. Where can we save it? Already made a folder for today's class. Enter example 1. So now let's run this. Okay, what happened? Typing mistake. This should be printf. So no errors, no warnings. Okay, can you see that? So address of C is some big number here. This is in hexadecimal. So hexadecimal base, it's not binary, definitely not decimal. So its base is 16.
Yes, sir. Because we can see E and F in it.
Yes. So we use from 0 to 9 these digits, 10 digits, and the first 6 letters. So A, B, C, D, E, F. So we cannot discuss basics or details of hexadecimal system here, but this is the address uh, in which C is located. And what is the value of C? This is 100. So again, address of pointer.
Sir, I think the address of the pointer will be, sir, 64. Means the bottom
Is
one.
it? Oh, okay, I made a
I
mistake here.
think,
Okay,
yes,
no,
sir, because
there is a
star
problem.
PTRC.
There is a problem here. I forgot to change this to percentage D. That was wrong. Okay, uh, this needs to be changed to percentage D as well. Now you can see that this is the
Sir, why the address of PTR C and C are same?
that should not be same. There must be a mistake here. This is the mistake. PTRC contains the address of C. So if you print PTRC, that would be obviously the address of
Yes,
C,
sir. Yes,
isn't
sir.
it?
Yes, sir.
Now you see that was a mistake on my part. I missed it. Now they are different.
Yes, sir.
It has to be different.
Sir, is there any specific pattern about what the next, what the addresses
Depends.
will be?
It depends on the compiler. Completely on the compiler.
And sir, one another thing, sir,
Yeah.
as you said that every bit will be means have a different address number. So
Mhm.
if we means place instead of integer, if we place a float, means integer have 4 bits. So why it is showing only one number? It must show means 4 numbers because the
It,
integer is located in means.
it shows address is usually the first bit.
Okay, okay. So,
Okay, the first one.
and so the
It-
next, the
just
three or the next consecutive will be
have a look
consecutive
at
ones.
this. Yeah, they need to be continuous.
Okay, sir.
This is 62FE14. This one 62FE18. This is the address of C that has been demarcated 4 bytes. Next one after 4 digits, that's what it comes out. Okay, not
Yes, sir.
necessarily every time it will happen like this. In this fortunate circumstances, it has come like this, that they are side by side. May not be side by side, maybe in some different memory locations, uh, but that is the most general situation that we can think of. We can further modify this. Suppose I write this is as 101. Now if we do this, I'll copy the same thing. the addresses do not change. See? But the value has changed. By the way, here also I should mention that sometimes in some compilers, you might get different address values from run to run. It's possible, but that depends on the compiler. Okay. We can also modify the value by doing this. I can access the address. This is how I have accessed the address of the variable C, and I have changed it to 102. Now, if I do that, now you can see that the content has changed inside this PTRC. That is the content that we are talking about, the value. The address, it doesn't change. Address remains the same. So this is a basic program that explains the concept of pointer variables. Let us now just go back to our presentation and proceed forward with the next topic. So this is just the same thing that we had done in the previous example here. I have highlighted that the same statement could have been written in this way. So star ptr underscore variable equal to 10. They are having the same meaning. Now let's talk about pointer arithmetic. C allows us to perform certain arithmetic operations on pointers, but certain other operations are not allowed. They are not valid. Now, what are unary pointer arithmetic? Increment and decrement of pointers. So the operator plus plus can be applied on pointers and it is valid. However, it does not increase the pointer value by 1. It increases the pointer value by size of data type. That means if you apply this operator plus plus operator, increment operator on an integer type pointer, its value will increase by 4 bytes, not by 1. Similarly, the decrement operator is also there and it subtracts size of data type number of bytes to the pointer. To explain that just a little bit more, let's take these two pointers. So int ptrn, that is the integer type pointer, and this is the long type pointer. If I do ptrn plus plus, this increments by size of int, that means by 4 bytes. Whatever is the value here, suppose this value is 100. The value inside this pointer is 100. So it's referring to an address of 100. If I do ptrn plus plus, if I increment it, then it is not going to be 101. It is going to be 104. Similarly, if ptrn lng plus plus is done, then the increment would be by 8 bytes because size of long is 8 bytes. If the address inside this pointer variable is suppose 200, then after this increment, the next value will be 208, not 201. It's quite typical here. So try to keep this in mind. Now we also have certain binary pointer arithmetics. We can add an integer to a pointer variable. So there's ptrn obviously ptrn would be having, it's a pointer variable, so it's having some address inside it. Again, I'm not referring to that as integer because it might be confusing. So we are adding an integer to an address. So what would be the result? The result is this ptrn plus n into size of int. It is not just ptrn plus n. So size of int is 4 bytes. So this is going to be n into 4. If inside this there was 104, then depending on n, that goes to 104 plus 4n. And that is only for integer type. If it was long, it would have been size of long, then this 4 bytes would have been 8. So it would have been 104 plus 8n. These are known as scale factors. Scale factors are important in case of pointer arithmetic. So you have to keep that in mind, that it advances the pointer by n number of ints, depending on obviously the type of the pointer. If it was float, then it would have advanced the pointer by n number of floats. If it was long, then by n number of longs. But adding two pointers like this, ptr1 is a pointer, ptr2 is a pointer, adding them together like this is not allowed. It's not a valid operation. However, this is valid. What does it mean? It means the value inside that variable which it is being pointed to, That is another one. These two can be added. Here we are basically adding two values. We are not adding addresses. So remember that addresses cannot be added, but obviously values can be added. We are using the dereferencing parameter here. That operator is being used here. So that means it is pointing to that particular value. So we are adding two values together. We are not adding two addresses together. But to make matters more confusing, ptr1 minus ptr2 is allowed. But there is a condition here. It is only allowed if they are pointing to elements of the same array. If it is different arrays or they are not related at all, then obviously subtraction of addresses is also not valid. It's not allowed. But it is allowed if they are part of the same array. And what is the result? The result is something like this. That is, if they are part of the same array. Now there are some examples here. We have considered two pointers, and the following expressions are some examples of valid pointer statements that are allowed in C. So you can do product or multiplication, but here you can see that we are using the indirection operator, dereferencing parameter, dereferencing operator. That means This is basically a value. This is also a value. So we are multiplying those two. There is no harm in that. It is allowed. Similarly, this is also allowed. That is another just another expression of the same statement. And so are these two. But remember that here, obviously, you are adding an integer, but you will be advancing the pointer by the size of the data type. Division of two values in an expression after dereferencing them using the star or asterisk operator, indirection operator is also allowed. So now we head to pointers and functions. Pointers can often be passed as arguments to a function. Basically, it can be done both ways. That means it can be passed to a function or it can be returned from a function as well. Because they are variables, it is also possible to pass pointers as input parameters to functions. And it is also possible to return values from functions as pointers. This becomes important here because if you remember the last class, we had mentioned that we cannot return an array from a function. It is possible to pass an array into a function, but it is not possible in C to return an array from a function. But using the pointer or pointer variable, you can pass the address of an array back to the main function or the calling function. That means you can return the address of an array. And by returning the address of an array, basically you are passing the array back to the calling function. So this is one of the big advantages of pointers. What we are doing here is explained in this particular statement that it allows data items within the calling program to be accessed by the function because you have supplied the address of it. So obviously now the function can also access that variable. It can be altered and then returned to the calling program in its altered form. Basically, this is known as call by reference. In our last class, we had referred to call by value. This is another sort of function call, which is known as call by reference. We'll now look at an example of call by reference. First of all, obviously, we'll get a look at call by value. This is just a recap of what we had done in our previous functions class. And then we'll see how call by reference can be effected. So this is a program to swap between two integers. This is the call by value. You can see that I have taken two numbers, 9 and 10. Num1 and num2 are the variables and they are initialized with values 9 and 10. Now I am calling this swap function, which is given here. The parameters being passed, num1 and num2. So the values of num1 and num2 are going to be passed into these two local parameters, n1 and n2. So 9 comes here, 10 goes there. So inside this swap function, now n1 has a value of 9, n2 has a value of 10. Now here is the standard swapping algorithm. And after that, what will happen? At this stage, n1 will become 10 and n2 will become 9. So there is swapping. So if you print their values here, this gives a value of 10. This one is 9. Then it will return back here. Notice that we are not returning anything to the main function. When it comes back here, it will print the values of num1 and num2. What is going to be printed here? What is num1? 9 or 10? No ideas? So this is going to be 9 and this is 10. That is, only the local values are being swapped. This is not going to be swapped at all. So that is call by value. In call by value, local copies are being changed, altered. It does not affect the original variables. However, that is not the case in case of call by reference. This is the call by reference example. And you can see that here in this function prototype, what we are passing is these things. So star n1 and star n2. So those are the arguments. This part is same. Same values have been assigned to number 1 and number 2. The call to this swap is also same, but here notice that we are having the address. This is address of num1, this is address of num2. So basically what we are passing to this is the address of these two variables, the original variables. Address of num1 is being passed to this pointer n1, and the address of num2 is being passed to this pointer variable n2. Inside here, same logic of swapping has been applied. These are now dereferenced values. So obviously values of num1 and num2 are going to be accessed here. And that ends the swap function. So it goes back here. And now if you print these two, the original copies have been altered. This is now 10. This is 9. Why does it happen? Because we are passing the actual addresses of the original variables. And that is what is being worked with. So the original data is being altered. That's why these values actually change. And this is the example of call by reference. Now pointers are arrays. Pointers and arrays also have a very close relationship together. When an array is declared, the compiler allocates a base address and sufficient amount of storage to contain all the elements of the array in contiguous memory locations. That means the memory locations are continuous. It is not like that half of the array is here and half of the array is in some other location. The memory locations are continuous. And the array is defined with respect to this base address. The base address is the location of the first element, that is index 0 of the array, And the compiler defines the array name as if it is a constant pointer to the first element. This is a typical thing in C that is done. That the array name itself is somewhat equivalent to a constant pointer. It is obviously not a pointer. In some texts, you might find that the array name is a pointer itself, but that is not exactly true. We consider this example that x5, that is a 5-element array, has been considered, and the elements are initialized as 1, 2, 3, 4, 5. So here we have the array. You can see the 5 elements here. So this amount of space has been allocated for it. The base address is this, and then the others are at a difference of 4 bytes, because this is an int array. So that's why this is 1004, 1008, 1012, and so on. And each of these memory addresses has received a value, values as shown in the declaration and initialization. So basically it is like this. X0, 0 is the first index, so X0 receives 1, and then subsequently all the elements are stored in X1, X2, X3, and X4 respectively. So basically, what about these addresses? These are addresses of the individual array elements. So we can access these addresses by using these syntax. So if I write X, that is the name of the array here, that is quite same as, sorry, they are equivalent. So this is equivalent to a pointer. You can quite easily write pointer. Obviously, you have to initialize this pointer first. And we can access successive values of X by using this notation, plus plus. We know that they are incremented by the size of the data type. Because it is int, the size of the data type increments by 4. P++ also increments by 4. So I can access the successive elements of X by using this notation. So the relationship between P and X, the relation between P and X can be written like this: star P, sorry, this is not that, star P plus I. That gives the value of xi. Adding the pointer with an integer. We have talked about this arithmetic addition in one of the previous slides. So you can refer back to that to get a better understanding of this. To elaborate on this, I can write it like this. This will be equal to 1000. P plus 1 is address 1, that is 1004, and so on. So quite obviously, if I do this asterisk p plus 1, I get whatever in this address is there. So I will get the value of 2. This one. Again, this is quite a complicated topic, may not be absolutely clear, crystal clear at this point. So further reading is required, and I request you, all of you, to have a go through the pointer chapter in any of the standard textbooks that have been mentioned and look at quite a few examples. The best way to master this is to do programs, right? Few small programs handling pointers, and that will probably clear up the ideas about pointers. So that's all for today's class. Thank you for your attention.